Assalamualaikum. My name is Muhammad Mujahid. So our group had choose water slide to become our case study. In our country Malaysia, we had one famous water slide which is Escape Theme Park at the Penang, which is the number one theme park in Malaysia. The Escape water slide is about 1,111 meters and long and takes about 4 minutes to ride from the beginning to the end. Based on the Escape water slide, this application can be linked to the projectile motion that we learn in the dynamic courses. As we all know, when the person slide down on the water slide to the finish, he became projectile. If a person travel too fast, maybe he will land at a dangerous point which may cause serious injury. This project has been implemented to achieve several objectives. Number 1, to identify whether the mass will affect the velocity at the free fall state. Number 2, to identify the length of the water slide suitable for the landing area. And for the number 3, to identify the safety factor which can be improved.
Assalamualaikum and hi, my name is Muhammad Farhan bin Namizi and I'm from Dynamic Section 4. So today I would like to describe about for my project which is for this case study. Okay. For this case study that will be study on this problem will be focused on the suitable length for the landing area. For the topic we choose which was the projectile motion. Discussion for the type of situation had been done to find the related and most suitable real slide condition. Study according to the problem show that it can be solved by manipulating the method from motion of projectile topic. As an example, simple one-dimensional type of projectile motion in which there is no horizontal movement. In this section, we have considered two-dimensional projectile motion. The number one, such as of a football, or the other subject for which air resistance is negligible. The length should be suitable so that the person using the slide will be not landing outside of the pool. For this case study that we study on this problem will be the focus on the suitable length for the slide which was the pool located underneath. The length should be determined with respect to the expectation of the weight of the person subjected to landing in the good condition in the pool. So for the topic we choose which was the projectile motion, discussion for the type of situation had been done to find the related and more suitable real slide condition for the study. And the problem showed that it can be solved by manipulating the method from the motion of projectile topic, which there is no horizontal movement. In this section, we consider two-dimensional projectile motion such as that of a football, other object which is air resistant.
Assalamualaikum. My name is Muhammad Hafiz Haikal bin Razali. Today I will present about the calculation. From the coordinate system, we know that the mass is 60 kg, height of slider is 12 meter, and the angle of projectile motion is 30 degree, and height between end of slider and pool is 3 meter. We use this formula mgh1 plus 1 over 2 mv square equal mgh2 plus 1 over 2 mv square. We use this formula to calculate v2. The answer of the v2 is 15.34 meter per second. After apply kinematic equation, we know that the velocity at the end of the slider is 50.34 meter per second. Next, at the part water pool, we need to know that is how long to pool should be built to make a safe facility for everyone. For vertical motion, Vy equal 50.34 meter per second, sine 30 degree, and we get the answer is 7.67 meter per second. We assume upward is positive. To calculate the time, we assume Sy equal to 0 and we use S equal S0 plus V divided by T minus 1 over 2 G T square, and the answer is 1.888 seconds. For horizontal motion, Vx equal 15.34 cos 30 degree, and the answer for Vx is 30.28 meter per second. We assume to the right is positive. So to calculate the distance need to build the water pool, we use the formula S equal V times T, and the final answer is 29 meter. So the water pool need to build longer than theoretical calculation.
Assalamualaikum and salam sejahtera. My name is Muhammad bin Azman with number matrix CD200-138 from group 10 section 4. Today I'm gonna talk about the analysis and the discussion from this project. First of all, we will take a look at the analysis from this project. First, we need to divide the system into two parts, which are slider and a pool. In the slider part, we know that the movement that occurs is free fall. Thus, by applying the conservation of energy and the kinematic equation, we can find the velocity at the end of the slider. By using this calculation in this case study, we know how far the person traveled in the 3 meter from the water slide to the base of the pool, and we can calculate the time taken of the user to fall under the influence of gravity. So we know the distance in the x direction and the time it took to travel that distance. Thus we can solve to find the velocity at the x-axis, which is Vx. Lastly, we link the energy and projectile motion of the problem to obtain a solution. We can now do this because we know the kinetic energy from the water slide into the pool, since we calculate the velocity Vx. If we know the kinetic energy at the last of this project, we can solve the potential energy at the top of the slide, and thus the height. After that, we will take a look at the discussion part. Projectile motion is the motion of an object thrown or projected into the air, subject only to acceleration as a result of gravity. The most important fact to remember here is that the movement along the vertical axis is independent and can therefore be analyzed separately. From the horizontal motion equation, we can find the value of the distance along the x-axis, which is 29 meter, and the pool that need to be built should have longer than the distance obtained. While by using vertical motion equation, we can find the time of flight of the user, which is 1.888 seconds. By using this calculation in this case study, it can help us calculate the appropriate length of the pool to be built so that everyone can play the facility without any danger. After calculation, we know that the speed is not affected by the mass in the state of free fall. In addition, after calculation, we also know that the higher the height of the slider, the greater the speed at the end of the slider. At first, there is no kinetic energy, but the potential energy is at its maximum. Although there is no potential energy at the end point, the kinetic energy is at its maximum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan bin Saiful. So right now, I'm going to talk about the conclusion of this project. So basically, what we have discussed with our group mates, we have discussed about the projectile motion. So projectile motion is basically is when an object is thrown into the air, and it is only related with the acceleration of gravity. And we also can relate this with the problem solving of one-dimensional kinematic, as it is related to the vertical and horizontal velocity. So because all of this, we can relate it with an application of a water slide at a theme park. Based on our discussion that is about the theme park water slide, so basically it is all about projectile motion. And as we know, when a person is sliding throughout the slide, and it will cause the person to projectile. So basically, the velocity of the human or of the object will affect where the person will land. So the last conclusion is that we can conclude that all the analysis is all based on the coordinate system, the vertical motion and horizontal motion, and also the kinetic movement. That's all. Thank you.